Good day, everyone. Today, I'm going to report about crop logging of banana. What is crop logging? Crop logging is a system of monitoring the nutritional status of plants by periodic and regular sampling and analysis of soil and plant parts. The primary aim is to be able to correct the nutritional problem while the plant is still standing and can benefit from the corrective measure. There are two general forms of crop logging employed in fruit crops: physical crop logging and chemical crop logging. Physical crop log includes plant height, plant biomass, number of leaves, number of branches, etc., whereas chemical crop logging emphasis is on the nutrient uptake of plants. Banana is the fruit of the plant of the genus Musae, family of the Musaceae, cultivated primarily food, secondary for production of fiber, used in textile industry, also cultivated for ornamental purposes. System of planting: single row system, paired row system, squared system, and triangular system. Single row system. In single row planting, the distance within the row is close, whereas the distance between the row is wide. This system allows good aeration to plant canopy, allowing wet leaves to dry more rapidly, reducing fungal disease severity. In this, less number of trees occupied in the field and yield will automatically reduce. Paired row system. In this method, the distance between the two lines is 0.90 to 1.20 meters, while plant to plant distance is 1.2 to 2 meters. Due to this spacing, intercultural operations can be carried out easily and cost of drip irrigation is decreased. Square system. This is the most commonly followed system and is very easy to lay out. Banana is mostly cultivated by adapting 1.8 by 1.8 meter spacing. In this system, trees are planted on each corner of a square, whatever may be the planting distance. This system is best suited for tissue culture banana suckers. In this, adapt spacing in between rows was 1.5 meters and plant to plant was 1.8 meters in the row. The trees are planted as in square system, but the difference being that those in the even numbered rows are midway between those in the odd rows instead of opposite to them. The distance between any two adjacent trees in a row is equal to the perpendicular distance between any two adjacent rows. Bananas can be planted using three methods: tissue culture plants, beets, suckers. Tissue culture plants are small plants which are grown from the tissue of banana planting bags and are ready for planting for hygiene reasons. This is the preferred method for planting bananas. Beets are small portions of the banana plant cut from the rhizome of the plant and a bud is attached. Suckers are shoots growing from the rhizome of banana plants and they grow into new plants. Morphology: inflorescence is a complex spike with a stout peduncle on which flowers are arranged in nodal clusters. Each node comprises two rows of flowers, subtended by a bract, which protects the young flowers. Flowers are predominantly unisexual. The plant monoecious and dichogamous proximal nodes bear female flowers about 5 to 18. Distal nodes contain male flowers tightly enclosed in bracts which form a conical structure or male bud. Hermaphrodite or neutral flowers may be present on the rachis stalk between the female flowers and male bud. Female flower have an inferior elongated trilocular ovary with three fused carpels, bearing six petals, five free and one fused, surrounding a thick style and non-functional staminodes. Ovaries of female flower later become the fruit or finger. Male flower have a smaller ovary, slender style, 5 stamens with long anthers that may or may not produce any pollen. Suckers. Lateral outgrowths from vegetative buds found on rhizome opposite of the leaf base. Peeper. Small sucker which has just emerged through the soil. Sword sucker. Narrow leaves and a broad rhizome base. Ideal type of planting material. Water sucker. Broad leaves, smaller rhizome, and weaker connection to the mother plant. Not ideal as planting material. Maiden sucker. Full-grown sucker bearing foliage leaves. Pseudostem. Looks like a stem or trunk formed by overlapping leaf sheets serve as vascular connection between leaves, roots, and fruits. Pseudostem height, aspect, and color are used to distinguish between varieties. Scale leaves are first produced from the central meristem of developing suckers, followed by narrow sword leaves and the broad leaves with wider laminae, and finally full-size leaves by 6 months. The distal end of the elongating leaves contracts into a narrow petiole, which continues into the leaf becoming a midrib. The midribs divides the blades into two lamina halves. The lamina develops inside the pseudostem as a rolled cigar leaf. Other leaves, senesce, and die, and new leaves emerge every 7 to 10 days. The final leaf to emerge is a smaller flagged leaf, which curves to protect the emerging inflorescence. Rhizome, true stem of the plant, has extremely short internodes covered by closely packed leaf scars, differentiated into central cylinder and cortex ground tissue is starchy parenchyma. It is a storage organ sustaining growth of the bunch and developing suckers. Meristem is a flattened dome form which leaves are formed and later becomes inflorescence. Root system is adventitious and mostly confined to the upper 40 centimeter of the soil. Roots originate in groups of 3 to 4 from the corm as primary roots, branching off to secondary and then tertiary roots. It is important for the rhizome to remain completely below the surface of the soil. A phenomenon known as high math arises when the rhizome is climbing out of the soil, resulting to plant instability and yield due to exposure of the roots. Landscape information of banana. Plant name, banana. Plant type, tree. Origin, Southern Asia, Indonesia, Malaysia. Heat zones, 7 to 16. Hardiness zones, 9 to 13. Uses, specimen, container, edible, wildlife. Size or shape, growth rate, fast. Tree shape, upright. Canopy symmetry, irregular. Canopy density, open. Canopy texture, coarse. Height at maturity, 3 to 5 meters. Spread at maturity, 3 to 5 meters. Time to ultimate height, 1 to 2 years. Botanical description, foliage, leaf arrangement, spiral, leaf venation, pinnate, leaf persistence, evergreen, leaf type, simple, leaf blade, 50 to 80, leaf shape, oblong, leaf margins, undulate, leaf textures, smooth, Leaf scent, no fragrance. Color, growing season, green. Color, changing season, green. Flower, flower showiness, true. Flower size range over 20. Flower sexuality, monoecious, bisexual. Flower scent, no fragrance. Flower color, orange, purple. Seasons, spring. Trunk, trunk susceptibility to breakage. Generally, resist breakage. Number of trunks, multi-trunk. Trunk aesthetic values, showy smooth. Fruit, fruit type, berry. Fruit shyness, true. Fruit size range, 10 to 20. Fruit colors, yellow. Seasons, spring. Horticulture management, tolerance. Frost tolerance, no. Heat tolerant, yes. Drought tolerant, no. Salt tolerance, poor. Requirements, soil requirements, clay, loam, and sand. Soil pH requirements, acidic, neutral, alkaline. Water requirements, high. Light requirements, full. Management, invasive potential, no. Susceptibility to pests and diseases, yes. Pruning requirement, no pruning at all. Fruit, leaves, or flowers litter, yes. Surface rooting, no. Lifespan, less than 25. Edible plants, fruit. Pest, nematodes, scales. Plant propagation, stolons. Nutritional value of banana. Energy, 371 kilojoules. Carbohydrates, 22.84 grams. Sugars, 12.23 grams. Dietary fiber, 2.6 grams. Fat, 0.33 grams. Protein, 1.09 grams. Vitamins and quantity percent. Thiamine B1, 3%. Riboflavin B2, 6%. Niacin B3, 4%. Pantothenic acid B5, 7%. Vitamin B6, 31%. Folate B9, 5%. Choline, 2%. Vitamin C, 10%. So here's the mechanisms of nutrient uptake. Nitrogen, root interception is 1, mass flow 99, diffusion 0. Phosphorus 3 for root interception, mass flow 6, diffusion 94. Potassium, root interception 2, mass flow 20, diffusion 78. Calcium, root interception 71, mass flow 29, diffusion is 0. Magnesium, root interception is 38, mass flow is 50, diffusion is 12. Sulfur, root interception is 5, mass flow 95, diffusion. Root interception is 10, mass flow is 40, diffusion is 50. Zinc, root interception is 33, mass flow is 33 also, and same as diffusion 33. Boron, root interception is 10, mass flow 35, diffusion 55. Iron, root interception is 11, mass flow 53, diffusion 37. Manganese, Root interception, 33. Mass flow is also 33. Same as diffusion. It's also 33. Molib- molybdenum. Root interception is 10. Mass flow is 20. Diffusion, 70.